Welcome to Chemistry at Hononegah High School. I'm Brian Brown, and today we'll be looking at our third day's worth of notes dealing with the mole. Now, what we're actually going to do today is we're going to look at the relationship between the two conversion factors that we've already talked about, Avogadro's number and molar mass, because they both involve a common unit, the mole. And that brings up a type of math problem we haven't practiced yet. So remember, the common thing between both Avogadro's number and molar mass is they both dealt with how many of something were in exactly 1 mole. In the case of Avogadro's number, the first one we looked at, it was how many particles were in a mole. And remember, the type of particle was either an atom, a molecule, or a formula based upon the type of substance that you had. And really what Avogadro's number allowed us to do was to convert back and forth between particles and moles. We could go from particles to moles, or we could go from moles to particles. We could do either one. Now, the second conversion factor we looked at related to the mole was molar mass. Remember, that was the mass in grams of exactly 1 mole. So with molar mass, and remember, molar mass comes from the periodic table, we had a conversion factor that allowed us to go back and forth between mass and moles. Well, look at the implications of this. If we could convert back and forth between mass and moles, and we can also convert back and forth between particles and moles, what's to stop us from converting from particles to mass and linking this whole thing together? So that's what we're going to look at today, is we're going to look at conversion math problems where we're going to be using both conversion factors potentially. You need to learn when you can recognize when you're only using one. You need to learn when you're only using the other. And then you need to be able to recognize when you're actually using both. And if you picture your flow chart, that's why I want to keep it in front of us, it's easier to see what's going on here. So let's say we were asked the question, how many water molecules are in 242 grams of water? So my given is 242 grams, and my target would be water molecules. So I'm starting here, and it's asking about molecules, which is a type of particle that's way over here. Well, when I have this type of problem, how do I get from point A to point C? Well, the thing they have both in common is that I can convert them both to moles. So really, in this particular case, I know I've got a mass. I know I'm getting to a particle. I can see right from the flow chart, this has got to be a two-step or two conversion factor problem. And remember, it's really important in all cases that you're writing your given and your target with the two parts, the type of measurement and the type of substance. Always include both parts or you're not going to get full credit. So I've got my setup here. I've got my 242 grams of water as my starting point, and I'm trying to get to molecules of water, two-part units in both cases. Now, at this point, we're going to take a look at the flow chart to see how many steps the problem's going to take. And that's something that we'd already talked about. We can go from mass to moles and moles to particles, so we know it's going to be a two-step problem. Now, remember the process is always the same. So when you go to set this up, just work the process for dimensional analysis. Do I want to keep it? What can I change it into? That's really what you're doing here. So let's start at the beginning. Do I want to keep it? Well, the it, remember, is grams of water, the whole two-part unit. No, I don't want grams of water. I want molecules. So since I've got rid of it, got to get rid of it, it means it's got to go on the bottom to cancel. Now, what is the only thing I can do with mass that we've talked about? Well, I knew by definition molar mass is the number of grams in 1 mole. So I have an equality between moles and mass. Well, the reason why I use that equality is because all I can do with it is change from mass to moles. So I'm going to go to moles because that's all I can do based upon the flow chart that we've looked at. Now, do I want to keep moles? No. So at this point, I'm not really done. But don't forget, in order to make this a valid conversion factor, we have to complete the numbers that make them equal. So we have to remember it's the mass from the periodic table of 1 mole. Well, hydrogen is 1.0. We've got two of them. That's 2.0. Oxygen is 16.0. 2.0 plus 16.0, 18.0 grams of water in 1 mole. Now, at this point, I'm in moles, I want molecules, I'm not done. So do I want to keep it? No. And you can see exactly what we're going to do next. We're going to take our mole amount and then we're going to go to our particle amount. So I don't want moles, so I'm going to get rid of moles of water by putting them on the bottom. What can I change moles into? Well, I could change it back to grams, but that's just undoing what I just did. So at this point, I'm going to change it into particles. Now remember, we always have to decide what type of particle we've got. Water, all nonmetals, doesn't contain ammonium. That's a molecular type of particle. So Avogadro's number is going to allow me to convert to a molecule. That's the type of particle I can get to. So I can go to molecules of water here. And at that point, I need the numbers to make them equal. So 1 mole of water is 6.02 times 10 to the 23rd particles of water. Multiply everything on out, round to 3 sig figs because 242 had 3, 18.0 had 3, Avogadro's number had 3. The other two were exact, so my smallest number is 3, so I'm going to round my calculator answer to 3 sig figs, and I get 8.09 times 10 to the 24th. So this is the type of problem that you're going to be doing in today's homework. And remember, the key is the flow chart. Now, on the test, you're not going to have this flow chart, so you need to be able to conceptually understand it and be able to visualize it. And yes, some students just prefer to write it on the test, and that's perfectly fine. But remember, every time you see the mole in a problem, we're going to get rid of a step. Because if I'm in moles, I can go straight from particle or moles to particles or straight from moles to mass. And those are my two options, is to go to one or the other. So if I see in my problem somewhere it mentions mole, I know it's not going to be a two-step problem. It's only going to be a one-step problem. But really, look at what they give you and look at what you're trying to get to. If they give me mass and they ask for moles, I can do that in one step. If they give me particles and they ask for moles, I can do that in one step. But if they give me particles and they ask me to get to mass, I'm going to take two steps to get there. So I've got to change my particles into moles in my first step and then moles into mass in my second step. And instead of a single step problem, it's going to take me two. And that's the type of homework you're doing in today. Remember, consistently use two-step units, set up your problem and work the process, but the flowchart can help you see, is it going to be a one or a two-step problem? And remember, when you're looking at the problem, if you see moles and you're giving it your target, you know it's not going to be two steps. It's going to be a one-step problem. Hopefully that helps you with your conversion math problems.